Everyone doing okay? Okay. So again, we have these 2 days now. Again, we were slated to do 11.4, which is one of the more complicated concepts, and it's not on the test, so I don't want you struggling with it and going off. So we're going to use 2 days for review. I did get a copy of the test last night, so I have reviewed it. It's similar to what was in the spring semester. Questions are a little different, but same type of topics. So the review questions that we have are going to be very helpful in preparing. So what I'll do is I'll first give an overview of what exactly you will need to know from these things, be able to do, kind of give an overview, and then we can take some questions and work through a few. I may work through in stating it. There's like a couple where I may just show the example, know the difference between this and this, but we'll do that. The test itself has 6 multiple choice questions, A, B, C, D. You just choose the right one. So you've got the question, you've got the answer. Unfortunately, you've also got 3 wrong answers. So it's just, but yes, I give you don't ever say I didn't give you the answers. I give them to you, but we also give you the wrong answers too. So you have to choose the right answer. So 6 questions like that. So it makes some of them a little easier. Like if you have to find a limit, there's a choice. You don't have to. If it's infinity, does that mean does not exist? Well, there's a choice there, and they won't. It's very extreme differences. So they don't have both do not exist and infinity. They'll have one or the other. Stuff like that. So 6 of those. There is one question that has 3 true-false questions attached. I really don't like true-false questions because to make a good true-false question, you need to make it tricky, but then you're not really testing, but they're there. And they're not too bad, but it's either right or it's wrong, right? So 3 true-false. We'll look at the content where it might come from. And it's one where you refer to a graph and you've got to say some stuff about that graph and rates of change and kind of like what we've done. And then there is 4, see a total of 12, so it's 6, 7. If I add 4 to 7, I got 13. 8, 9, 10, 11, 12. Maybe that's 5. I just didn't know. Okay, so there's 8 to 12. So the questions 8 through 12 are open answer. And they expect you to show your work. The other ones you don't have to. In multiple choice, you could just choose it and you're good. However, if you do show your work and you get a wrong answer, we can look back at that and say, hey, you were on track or something. I can give some partial credit. But it's not required for the multiple choice. But for the open answer, you have to give some work. Now, I don't grade, is this work acceptable or this one? First, try to get the right answer. So if you've got a right answer, you'll get most of it. And then you've got some sort of supporting work. I'm not going to grade you, oh, you didn't put this step in. Maybe you did that one in your head. But you have to show that you know what you're doing, that you didn't just look on somebody else's paper and or something. If you use your graphing calculator, sketch a graph. What did you put in? Something like that. That oftentimes helps because if you put in a wrong, a negative instead of a plus, it'll show up on the graph, and I can say, well, you had sort of the right graph, but I can tell. So again, as much as you show, the best. But 6 multiple choice, 1 with 3 parts that are true-false, and then 5 open answer. And some of them have multiple. They kind of walk you through. So, but there's room to show your work and go through. You can also bring scratch paper if you'd like, because my scratch work's real messy, and then I have to rewrite it. But it's up to you. Okay, so you can use scratch paper. No notes. So we'll discuss that. I don't think we do have the product and quotient rule will be on the test, so you need to know those, but they don't provide them. Okay, so let me kind of go for an open-ended review. So there's a couple here on calculating limits, right? And there will be a question about limits. It's not a test completely about limits. So for these, what you want to do is you want to remember that what we consider when we look at the limit going to infinity is the largest one, but when we're not going to infinity, so there's just this one, these ones, a couple things we can do, right? This is, if it's not going to infinity, what we're looking for is what is the value as we get close to that number. So on this one, x is going towards 2. We may be able to just plug in 2 and get that answer, and we'd be fine. Okay, that's all you would have to do. And I think that would be fine because there's nothing 2 does not make it undefined. This one down here, 3 times 13 is not 26, so I think we're okay. So I think with all of these, you can actually just plug in the number. So it's almost, you don't even have to know what a limit is for these ones. You could plug in the number, and that's going to be the limit. That's the same as if you were to just kind of get close to it. Okay? So that's that type of limit question. There could be one where it is undefined, and then all you're doing is you're graphing it, and then you're looking as it gets close to that value. Okay? When x goes to infinity, remember, we're going to be there's a couple of general rules that we had. And one is, especially when we have a ratio, if we have some number, and I'll just put 1, it could be any other number, over infinity, what does this go towards? 0, right? Because we're dividing by a big number, so whatever's up here, this one will go to 0. But if it's the other way around, if infinity's in top and there's a number in the bottom, what happens there? It goes to infinity, or negative infinity if it's going to negative infinity. And sometimes we would say the limit does not exist. But again, it'll be one of those two, because infinity itself is not a number. Okay, so there's those two concepts. And when we're doing a ratio, remember, there was 3 things that could happen. One of these 2 could happen, or if all we have to do is look at the largest degree, and then since this one, the degrees are the same, so the first thing is same degree. Then it just becomes the ratio of the numerator over the denominator's coefficients, those numbers, right? Because everything else cancels out. In this case, the x to the third would cancel out. That's going to be the limit. Okay, so that's one case. Second case, the degrees are different, actually for the second and third. Let's see, let's do the top degree is bigger. The top degree is bigger, what happens? There's an x left in the top that's going to infinity, right? That's this case here. So it would go to infinity, or negative infinity if it was a negative in there. Okay? Depends on which way it's going. And then the third thing was the top degree is smaller or the bottom is bigger. I like to focus which one, I just look for which one's bigger. Okay, so I'll just go with bottom bigger. The bottom's the bigger one, then we're talking this one up here, where there's still an x left in the bottom, that goes to infinity. We're dividing by infinity, that goes to 0. The cool part with this one, it doesn't matter if it's positive or negative infinity, it always goes to 0, right? Positive 0 and negative 0 are the same number. So this one goes to 0. So those are the 3 things that can happen with that limit. Okay, so no, basically, it looks complicated, but all we have to do is focus on the largest degree. Okay. And remember, for this practice exam, I'll call it, or a review, because there's a lot more questions on here than you'll actually have. But it's good because, like for two, there'll be one question like this, but you don't know which one of these you're going to get. So you kind of have to know the three different cases and stuff. Could be a simple one, could be, but you know, if you know them all, you'll be just fine. But there's a solution guide for this, and in that solution guide, there's some that give some fairly good explanations of why one's correct and why the others are false. There are some that just gives the answers, but pull up that answer key as well, or solution guide, I guess. So that's there. And then, again, we also have Thursday. We can go over things. I am recording this, so this will be posted. Wednesday, I have a review session with my Wednesday class. I'll record that one as well. So there's all these different ones. If you need additional assistance, contact me. We've got office hours the rest of this week, and I'll make myself available. So I think I can do it Friday. Yeah, Fridays usually my work from the home office, so I can pop on for a few minutes, 30 minutes, whatever you need to answer a few questions about these. The homework I have moved till Tuesday. Hopefully you can get it all. I mean, it's going to be most powerful if you can get it all done by the exam. However, I'm kind of a soft when it comes to that. If somebody really needs it, I can extend it to the following weekend. The thing is, homework points aren't going to get you through the test. You have to pass the test. So, but some people do well at looking at these reviews, studying and learning it. The homework is maybe taking them more time. So if you're one of those, don't worry. Focus on what you need to focus on. I want to give you that freedom. So if you find that, hey, I'll do better on the test if I start focusing on this than the homework, and I know Little Crow will let me have the next weekend to finish up the homework, I will do that with you, okay? Because I want to honor your way of studying for exams and learning. And you'll do it one way or the other, okay? So everyone, it's till Tuesday at midnight. However, if you want, we could do it longer as need be. Okay, so that's pretty much limits. Let's see, got to go down here. So again, these all fall pretty much under that. I guess there's one I didn't really address, something like this. Remember, we had something, if there is an exponential, and it could be any base. They'll use e a lot because that's the natural number. It could be any number to the x. And remember, if this is the limit as x goes to infinity or negative infinity, this one is just going to go, because it's x5 is just going to get to a really big power. This goes to plus or minus infinity, depending upon what's happening here. This one, I'll make it different. So this is the only other case we really need to look at. Remember that negative exponent makes it into really a fraction of 1 over 5 to the x. So that's going to go to 0. Okay, and just be careful. Remember, in limits, sometimes they have like a formula. I think we don't have as complicated as that, but that means that part goes to 0. If it's multiplying by something, that goes to 0, but it could be adding or subtracting to something, but you have to.
In one of the homework problems, it shows e to an exponent in the denominator.
Very good. So, but in the denominator, is it positive or negative down there?
Negative.
So if it's negative down here, what we know is that down here, this is going to go to 0. And I think I know which one you're talking about. It maybe does something like this. So if this goes to 0, this part goes to 0, but we still have a 1 there, or we still have something. Okay? And then we have to do what's ever in the top. But it's just like that little piece, the piece with it, that's going to 0. So we could just basically replace it with 0 and then do the calculation. So that's the key part. And I've worked a similar one, like either that one or a similar one, and some of you have put in the answer as 0, and you're kind of on the right track. The part with the limit, e to the minus x, that does go to 0, but the whole thing goes to something else because we plug in that 0 and then we carry out the calculation. Thank you. So if there's a 5 up here, this one, as x goes to infinity, this actually would go to, and I'll do this as 5 over 1 minus 0. This would go to 5, right? So that e part goes to 0. Good. Okay, so there's that. Oh, yeah, there's one right here. So yeah, this part goes to 0. So you're going to get 1,500 over 3 divided, and that's 500. So yeah, so you'll see those type of things, and there's those ones. Then there is we kind of get into rates of change, and there's two key types of rates of change that we're going to talk about that's kind of embedded in here. And I liked it on the exam when they ask from, they do put this part in bold. So there is average rate of change, and what's the other kind of rate of change we do? Instantaneous. So there's two different things. So average rate of change, that's our secant line, which is a line with 2 points. We're going to connect it, and we're going to get the average between those 2 points. So like this, the average rate of change between 2 and 6, we only look at 2 and 6, and remember this is really just the slope of those 2 points. So you could think of it as y2 minus y1 over x2 minus x1. Okay? So that's average rate of change. And there's some questions we'll ask actually for both of it. They'll ask for the average rate of change and the instantaneous rate of change. Average rate of change. Now, here they gave us the table. Remember, they also may give us a function. And so we need an x and a y, an x and a y. They'll give us the x values, but not the y values. We've got to plug that in our calculator or do the calculation, get the 2 y values that go with it. But whenever they want average rate of change, where we're always working from is we need 2 points, x1, y1, and x2, y2. That's the only way we can do average rate of change. Find 2 points, find their slope, and we're done. Okay. Instantaneous rate of change, which will probably be further down, but and that was usually a little bit further. Instantaneous. Well, I'll abbreviate with instant. I can't remember how to spell. In fact, my 7th grade teacher, in my end of the year thing, she wrote to my most creative speller. So I thought that was a nice twist. I'm a creative. I'm not a bad speller. I'm just creative. So the instantaneous rate of change, remember, that is the derivative. That is the slope of the tangent line. And remember, the slope of a tangent line is going through at 1 point. It's not 2 points. So don't go trying to get 2 points because you can't. Right? It's the slope of a tangent line. So we need a derivative, or we need if they give us a tangent line, that could be instantaneous rate of change. So those are the two different things. Instantaneous rate of change is a tangent line. So the instantaneous rate of change has a tangent line, the slope of the tangent line. The average rate of change is the slope of the secant line. And slope is this concept of rate of change. That's what it is, right? It's how things are changing, how we're getting from one place to the other, so what that changes. But make those differences. Okay, so kind of review that. So these ones are primarily, they're giving us points. We've got to get 2 points, average rate of change. We did a lot of those. And remember, it's a calculus concept, rate of change, but at the same time, we're using algebra to do it. We really didn't get to calculus until instantaneous rate of change, and we combined limits and limits of bringing 2 points together. So then we've got the slope of a tangent line. So those are the big ideas. See, there's that. If given a graph, you're going to be asked, and there's similar to this, there'll be a graph and they ask you some things about the derivatives. When we're talking derivative and we're looking at a graph, what are we using to represent that derivative? Give you a hint. F prime, but geometrically, because we're looking at a geometrical figure, right? What do we use? A pencil, which is kind of like a straight thing, which is like a line, and it's a tangent. So we're looking at a tangent line. And again, I apologize that our learning materials don't have more interactivity in the homework. It would be a lot easier if we had this graph and you could actually draw, had a little tool that put all the tangent lines. But maybe that's what they're, sometimes they do these things on purpose and sometimes they're just trying to save money. But you have to think, okay, if I've got a tangent line over here, it's going to kind of go through at one point. So that tangent line, what would that sign of that tangent line be since it's going downward? It's going to be negative. And then when I get here to the bottom, oh yeah, that's right, the tangent line can only go through it. Oh, that's going to be horizontal. On this side, it's going to be kind of going up. But be able, do some practice with tangent lines and graphs. Because, and again, they're not trying to trip you up, but they're trying to see if you understand this concept. Okay? So whenever we want a derivative, if we're looking at it, we can use a tangent line. And incidentally, I'm going to show you, I want to get a full review, but I'm going to also show you with the TI-84, there's a way to get the equation of the tangent line, because that's another thing that's in there. And again, all you have to do is put it in, and it will get it for you, so we'll be good. And I have a Casio. I will do that in a later recording because I'm not really set up. I don't have an emulator, so it wouldn't record. But I'll do that for the Casio, and I'll also do it for NumWorks because it's pretty quick. So I'll put in, I should probably be able to do that either later this evening or possibly tomorrow afternoon. I'll do maybe like a 20-minute video of all the ways you can use a calculator to do some of this stuff. And because it will actually find derivatives for you. There's ways of doing that, and I'll show you that for the TI-84, the Casio that I have, and NumWorks. So I'll make 3 different videos, and then you choose whichever calculator you have if you want to see some additional calculator techniques that maybe you've been using or maybe not. Okay. Okay. And again, sometimes be prepared to see a graph, be able to calculate the average rate of change. And here's some of the types of true-false. So again, the true-false questions similar to these. It's only 3 of them, so it's not all of them. But again, you're going to want to kind of go through and again, true-false questions are just tricky. But they do they're supposed to test whether you really know the concept or not. I find them that they can't be obvious, or they try to make them not obvious, otherwise it's not a good question. But in doing that, they oftentimes seem sort of tricky. But practice these, because that's kind of what the true-false is taken from. You'll have a graph, and then they'll ask some questions about it, true-false, about the rate of change. Let's see. And then there's there'll be a few on using the power rule, product rule, or quotient rule. Constant multiple rule is, it's kind of built in. I don't think of that as different. And just remember, power rule is simply if we have 3x to the 5th, its derivative will be the 5 comes down, 5 times 3 is 15, x to the 4th power. So we're subtracting 1 from the exponent. You'll see x to the n equals n times x to the n minus 1. So if we take this derivative, right? So that's what we've been doing repeatedly. And it's really it's the basis of what we need to move forward. The product rule, we did that last Thursday? Today's Tuesday, yeah. So the product rule, remember, was whenever we had two functions, and I used f for the first function. Let's see, let me do this. F times s. That if we're going to take this derivative, it's the derivative of the first times the second with no derivative, plus the first one without a derivative, and then the derivative of the second. So it was just, and remember we broke it down to 4 pieces, and then put the pieces together, put it back. When we had a fraction with a top and a bottom, then the derivative was the top, and notice it's really the product rule again, but you'll see a fraction here. It's the top derivative times the bottom, similar to that, but instead of plus, it's minus, because when we take the derivative of the bottom, it's like b to the minus 1 power, right? So that's where that negative comes from. T times derivative of b. And remember, whenever we had something in the bottom, when you took its derivative, it was negative 1. So when you take its derivative, negative 1 minus 1 is negative 2. We end up with a bottom squared. Okay, so it's not that you have to know all the way, but think about what happens when we take the derivative of a fractional item, and that helps you remember it. Again, you can't sit, it depends on your style, you can sit and just memorize these things. For me, that doesn't work. But using them again and again, when I work problems, I rewrite those formulas. If I do that enough, I'll remember them. And I'll remember them correctly. When I try to memorize, I mess up. I put the negative in the wrong place and all sorts of things. Okay, so that's basically, go here, I think it goes up. So you can see there's some product rule here, there's some quotient rule ones to practice. And again, I would say there's maybe one of each. So we've got 12 total questions with parts and stuff. 6 and 5 is, yeah. But know how to do them, right? Know how to do them. And these all, from the types I've seen on the exam, these will all be good examples. Here's a good place. So I'm going to show you how you can do this both ways. So there is a question. They give you what's the slope of the tangent line. Okay. We can get the slope of the tangent line, and again, you could use this in multiple ways. But you could use the easiest ways as well. So we do know how to take a derivative. So remember, to find the equation of the tangent line, we would find its derivative. That would give us our slope. And the thing is when we look at a tangent line, all of these, a line, an equation of a line is always y equals mx plus b. Okay, so that's what we're doing. The slope of the tangent line will give us the slope, the m. We've got to find the y-intercept, which is something different. Or we need to know how to use our calculator. See, hopefully, I should have opened it up earlier. Lately, the calculator just opens up for me, so hopefully it will. TI-84 I'll use, because it'll show up here. I think I've shown maybe one or two of you this already, and I said I would make it sign in. And I did it with this account. Yeah, TI is a good calculator. It's not necessarily there's some that have other features, but they did give me a 3-year free license. They do that to teachers so that we will use it, then you'll buy it. So that's how they do their marketing. Casio doesn't. They charge teachers for the use of it. So first step for using this is we need to put in the function. And so whatever the function is, don't take the derivative, just put it in, and the calculator will handle everything. So I'll do this one up here, 3x squared minus 4x plus 6. Let's see, I think I will. Here we go. Well, clear. What was it? 3x squared, arrow over, was it minus 4x? And then it was plus 6. Okay, so whatever you're doing, and what you see is down here is there's a key press history, so you can kind of see all the keys I've hit. With this, you'll go to graph, and what I'm going to do is first is I'm going to go to zoom number 6, because that gives me a standard window depending upon what I've been doing. Standard windows like this. Here's my graph, and it wants us to find the equation of the tangent line. I think it was x equals 2, so that's important. Watch what all I have to do now. Since I have it here, I see 2. I can almost visualize where it is. It's not too intuitive, but what I'm going to do is there's this feature. If you look at the program key, I don't know if it's real clear there. Right above the program key, it says draw in blue. We're actually going to draw the tangent line. So just remember that's what we're doing. So I hit the second button, which is blue, and I hit the program key, but it's now going to do the blue thing, which is draw. There's my tangent line number 5. I just arrowed down to number 5. I'm going to hit enter. Now here's where the unintuitive part is. Okay, give me the tangent line. Well, it's not going to do anything. You can wait as long as you want. It's waiting for you to put in where do you want the tangent line. We want it at x equals 2. All we do is hit the 2 button. It doesn't seem intuitive, right? But if you hit 2, then it says x equals 2. It would be nice if they put the x equals and have a flashing thing to say this is where you put it in. Okay, x equals 2. We're going to hit enter and watch what happens. It draws the tangent line just like it said, but more importantly, it gives us the equation of the tangent line here. We are done. We have the slope. We have the whole equation of the tangent line. Y equals 8x minus 6. Write the answer, choose the answer from the list, whatever it is, we're good. It says show your work, draw a picture of this graph, and I'm fine with that. I can see that you've used a technological way to do that. The other way is you get the derivative, you plug in 2 for the derivative, that'll give you the slope of 8, but then you also need a point, and so you have to put that 2 in the original function to get the y value, so you've got the point, and then you have to either use slope point form or something to figure this part out. So there's some algebra behind it, but again, I want to honor your chosen field is business, some form of business. You're going to use technology to solve these problems. You're not becoming math teachers. If we were math teachers, maybe we'd go through all the process of doing everything by hand so you can teach it. But you need to be able to use the technology to get where you want to go. Okay? And remember, the only reason we use this tangent line is it does give a good estimate if we're close to there. Okay, so I could actually use that tangent line to estimate what would happen at x equals 3 and go off the tangent line. Remember, it's going to be an estimate. We do that. That's really what we're doing when we do a marginal. We use the tangent line. So we have that slope of the tangent line. But it's an easier function to work with than the original. But that's there. And again, I'll do brief video for those of you who have the Casio. I think a few of you do. And then also show the NumWorks. NumWorks actually is a little bit easier because it gives you don't have to go to some other place. It just gives it. So, but it's a newer calculator that I just found out about over the summer. So we'll go with that. But that's the tangent line. And again, we could also do some problems sort of the old school way. And when we get answering questions, we can do that. But know how to find the equation of the tangent line. And again, we get into this thing of average velocity, instantaneous velocity. Velocity is just the first derivative of a position function. So they give you some function that tells you how high a point is, how far a point is, location of a point. When you take its derivative, what do you have? You have the rate of change of that position. That's speed, that's velocity. Okay, so and again, that's more of an engineering type application, but it's in here. So, but what would average velocity be? Slope of a secant line. We need 2 points. Anytime you see average rate, I need 2 points, and I just need to find the slope. Just translate it. If I want instantaneous rate of change, I need it. Did I say that right? Secant line, 2 points. Tangent, for the instantaneous rate, I need a tangent line, which is 1 point, or a derivative. Both of those will do it for me. Okay, so kind of those are the two options we really have. Marginal analysis is it's an application, so the skill part is not anything new, except remember it's going to involve our business functions, our business relationships. We're going to have and I encourage you to write these down. Remember that profit is always equal to the revenue minus the cost. And just be careful when, sometimes cost is a complicated or a longer equation. Remember to put this parentheses because that negative, that subtraction, the whole thing gets subtracted. So it's got to distribute through. So parts of that cost function that were positive become negative, parts that were negative become positive. That negative has to distribute through. And I've seen you've seen me. I make that mistake. I'll put it to the first term and I forget to change the other terms. So I do it, we all do it, but just be careful with that. Okay, so that's a main part of this. And just remember, there's two things. We're either trying to find the value of the profit, the revenue, or the cost. Those are the original functions that we were either given or found. Or we're asked for the marginal profit, marginal revenue, marginal cost. To get the marginal, what do we need? Derivative. Where marginals are working with the derivative. So just translate that. Again, we take the derivative. We could get a tangent line. But most of what they're giving us, they give us functions. So if I want the marginal, I'm going to have to take that derivative. And again, they may give us a cost, they may give us a revenue. If they're asking about profit, it's always revenue minus cost. Set it up, show it, and we're good. Okay. Again, the math skills for doing that is again mostly is algebra and the initial setting it up. But no new skills as far as how to take a derivative, right? Those are the other ones. And notice that's why they have this as the last one. They did 11.3, which we just did. Yes, they actually addressed it further up with, so there's sort of the abstract, just here's take these derivatives. This is a application, and then what does it mean? Okay, and I'll just, they're on their marginal, it's in the open answer part, and they will ask you to write a sentence about what it means. So remember about units, marginals are going to be dollars per unit, dollars per suit. And again, I'm not going to get real technical. Is this right or this right? It's if you're on the right track, and I got ones wrong. I remember in the homework there was one that was I put dollars per unit. It says no, you need dollars per suit because they were talking about a suit. So okay, that's fine. But same concept. So again, just show me that you understand what the concepts are in general, and we'll be fine. So that's the review. Where are we? We still have, we go till 8:40, so we got about half an hour. Questions?
Just instantaneous rate of change, slope of the tangent line, marginal velocity, all of those mean derivative?
Yes, yes. Yeah, velocity is going to be a derivative. Marginal is going to be a derivative. It's going to be, yeah. And all we've talked about is the first derivative. I can't remember. I think that's all we need. Second derivative is not a big deal. It's a derivative of a derivative, and I can't remember if this class we do it or not. But yes, just so far we just do the derivative once. Velocity, marginal, tangent line. Those are all the derivative, different ways. It's the rate of change. Yes, sir. Sure, sure. Let's see. There was one in here. Tangent lines. Oh, here we go. They only give you one question, but we could, you can also go back to the homework, and we'll do that. So, assume that the distance s in meters traveled by a car moving in a straight line is given by this function. So again, as we read over this, the important part is this function. And this is a location function. It tells us how much distance they've traveled, right? So remember, what is a derivative going to be? It's going to be the change of the y over the change of the x. So this is giving us, if we know how long it's been traveling, we know how much distance it's gone. The derivative would be the change in distance over the change in time. That's what we call speed, miles per hour. So that's why the instantaneous rate. So, and this is a good one. It gives us the difference between, we're asked to do both the average velocity from 1 to 4, and then instantaneous velocity at t equals 3. Okay. Let me go ahead. So we've got this function. I'm going to put it in, and I'll show you how you can use the calculator. But remember, for average, we need 2 points. We need when x is 1, what is y? When x is 4, what is y? And then we can get that slope. So we could plug in 1 and we could plug in 4 and we could do it all that way, or we could come to our calculator. Let's see, good, that's showing. I'm going to clear this out, and instead of t, I'll use x squared minus 3x plus 5. And I'm doing this for 2 reasons. It'll ease it up, and then I'm also going to show you one more new little feature. It will actually take the derivative for us for instantaneous rate of change. But what I want to do is I want to find the y values for 1 and 4. So I go to my table, and actually I'll go to table set first. It's starting at -2, that's okay. It's changing by 1, it's on auto, that's good. So I'll go second table, and when x is 1, y is 3. And when x is 4, y is 9. So 3 and 9. Come back here. So I used my calculator just to get the y values, and now I've got my 2 points, and I just need to find the slope. So I'll do the second point, 9 minus 3. So notice I'm subtracting the y values, and then I subtract the x values in the denominator. 9 minus 3 is 6. 4 minus 1 is 3. 6 divided by 3 is 2. And what are my units? Because that's sometimes they ask us. This is, so the distance is in meters, and t is measured in seconds. So I could say this is 2 meters per second. Okay, and that's an average rate of change, right? I got my 2 points. The second one is to ask for the instantaneous velocity at the time the car at t equals 3. So that's in between that. And again, I'm going to, so the method would be take its derivative and plug in 3. Okay, so we could do that. Let's go ahead and do that first. So the derivative of s of t, derivative of t squared, 2t to the first power, derivative of negative 3t, negative 3, right? The t is gone because it's really t to the 0, which is 1. And then the derivative of 5 is a constant, so that's 0, plus 0 if you want, but okay. And then we want that derivative at 3 seconds, so we plug in, so s of the derivative at 3 is equal to 2 times 3 minus 3, so that's 6 minus 3, 6 minus 3, 3. I was going to go with 2, and I was going, they're the same, but no, it's 3. So be careful. I always throw off my arithmetic. 6 minus 3 is 3 still. Okay. And what is this? This is meters per second as well, because it's a rate of change, but it's an instantaneous rate of change. Okay. A way to check it, and again, I don't know if I've shown you this. I don't want that one. Way to check it, since I have it entered here already, right? Here it is. If I go to the graph, let me show you another tool. If I go to the calc tools, so this will be second calc that's above the trace key, second calc. Notice number 6 is dy dx, that's derivative. It's going to find the derivative at 3. It won't draw the tangent line. You could do the tangent line if you wanted, but here's it's a simpler way. I'm going to hit enter. And then again, it's just waiting. I have to enter where do I want that derivative. I'm going to put 3. And then you see x equals 3. I'll hit enter.
Unknown caller.
Sorry. And there it is. dy dx equals 3. It also gives me the point on the graph is 3, 5, and it shows that's where it's at. But it gives me the derivative is 3. So here I did the handwork. If I have to show my work, I took the derivative. I got it 3. Oh, this says 3. I feel good when I got verification. Because I was thinking, I was doing 6 minus 3, and I was coming up with 2. Honestly, I was. And then thanks for saving me on that one. I could have just kept quiet, but I didn't. Because I would have probably written down 2, and then I do the, wait, 3. It's not, 6 minus 3 is 3. I did an arithmetic error. But again, if you show your work, I can find that, that's a simple arithmetic error. But this will do it. Again, if you wanted that slope of the tangent line, you could also do that, right? So second, and it's good to do these things multiple times, second draw, because you get into the test, you're going to have a little bit more stress. It's hard to remember, but if you do things again and again, there's something called muscle memories. You might forget, but your finger will remember which buttons to push if you've done it enough times. You get this sort of natural. We have any athletes? You've played any sports? You know this. The reason you practice so much is because when you're out on that field playing that sport, you need to just react. You can't think. In fact, sometimes the coach don't think, just do, right? But you had to practice it first. Same thing with this stuff. The more you practice, draw the tangent line. Let's do it at 3. And again, we get we get the slope, 3, but this one doesn't tell us it's the derivative, but the 3 is the slope of the tangent line, so that is the derivative. We've got the full, and it's showing there and everything, and we're good to go. Did that help? Okay, so, but notice that difference. Average velocity, or average velocity, average rate of change. We need 2 points, get 2 x and y's, and just take its slope. It's a completely algebraic process, really. Instantaneous rate of change, that's where we get into the calculus. We're going to take a derivative, and we're going to find, because that's the only way we can find slope at a point is with a derivative or with a tool like this that will do it for us. Okay, and again, I'll make a little video and I'll have something like this in it. So, I'll try to keep it to 15 or 20 minutes. Just sort of these are specific things that will help you on the test for using the calculator. And again, you could use them to verify. But again, if you can at least get to the right answer, you'll be good. And I'll do it for the Casio as well, because I know a few of you have those. So what else? Other questions? Okay. Yes, sir.
I struggle whenever there's like a square root of x.
Okay.
Like x to the square root 4 times square root of x, or like x to the power 5 times square root of x. So I don't know if you're able to go over something like that. Or even like the differentiation, the review, if you can do like e, it's 8 over the square root of x minus 4 over x.
Sure. Let me see. Let me the new document. Give me that. Let me get my pen set up here. Give me that question again.
8 over the square root of x minus 4 over the square over x. I'm sorry.
Minus 4 over the square root of x?
Minus 4 over x.
Oh, over x, okay. Oops. Okay, so this will get both of them. Again, remember when we're taking this derivative, we want to do a little algebra first, and we want to rewrite these in terms of x to a power, because that's the only way we know how to take a derivative at this point, is x to the power comes down, and we subtract 1. So we're going to rewrite this now, and the thing is when we do this, if there was a number down here, notice this is in the denominator, I'm going to rewrite it as 8x, and what would the power be? Well, because of the square root, it would be 1/2. Square root is 1/2 power, and because it's in the denominator, it's going to be a negative 1/2 power. Okay, so that's not calculus yet. That's just algebra. It's this thing with exponents. So this kind of might be something you did 7 or 8 years ago. Who knows? But that's what's expected to know. And then when we've got 4 over x, the x is going to come up, but it'll be x to the minus 1 power. So that's just algebra, rewriting it with x to an exponent. Okay. Now we're set to start taking this derivative, and so I'm going to change colors on here. So remember, the first part of taking the derivative is whatever this exponent is, it comes and multiplies by whatever that coefficient is. So we're going to get negative 1/2 times 8. And sometimes the thing is we write this as just 8. I'm going to write it as a fraction. It's really 8 over 1, because that's some of the times I see is the problem is what's in the numerator, what's in the denominator. If it's just on the line, that belongs up in the numerator, and it's really 8. Think of it as 8 over 1. This x is still up in the numerator. The second part to do is we're going to subtract 1. And remember, whenever we're dealing with a fractional exponent, fractions need common denominators. And yeah, that's even further back. That was probably 3rd or 4th grade that you learned that stuff the first time. And and then we don't, they just, everyone's expected you to remember it. But, those are the things we kind of forget because we learn all these other rules. So I'm going to subtract 2 over 2. That's another form of 1, right? 2 divided by 2 is 1. So I have a negative 1, and then what we do is we subtract, we do the numerators. So I'll come over here, minus 1 minus 2 all over 2. So that's going to be negative 3 halves. So that's, and I'm going to put it up here, x is up in the numerator at this point, is negative 3 halves. So far so good? I mean, it's, the steps. Probably the difficulty is to put the answer back into that form. But I'll also do, if this is an open answer and you leave it as x to the minus 2/3, I'm completely happy. I'm fine with that. You'll get full points. Okay, but I'll also show you how because you might see the answers. And some of these, if they're multiple choice, they might choose to put the answer as a square root. And if you haven't seen this done before, you might not, where did that come from, right? So we'll come back to that one, but while we're there, let's go ahead and take this derivative. So the negative comes down in front. So negative 4 times negative 1 is going to give us a positive 4. I subtract 1. This becomes x to the minus 2. And I'm just going to put all of that's over 1 just so I see it's a fraction. Okay. Now I'll switch back. This is really algebra mode again. So what's going to happen is 1/2 times 8. So that's really 8 divided by 2 is going to be 4. So in front, we're going to get negative 4. Up in the numerator. And then this exponent, since it's negative, it'll come down here. And I'm going to leave it at that for now. This one, the 4 stays in the numerator. The x to the negative 2 goes down. And again, we could have left these up there with negative exponents. That would be okay. You should at least take 8 divided by 2 and give me 4 instead of 1/2 times 8. But, so one alternate version is 4x to the minus 3 halves plus 4x to the minus 2. You circle that. That'll get full credit because that's a correct answer. This would get full credit because it's a correct answer. And I'll show you one more version that you might see. This x to the 3 halves, think of it as x to the first times x to the 1/2, right? Or 2/2, because you would add these exponents, right? So what they do to rewrite this is, well, x to the first is just x. What's x to the 1/2? That's square root of x. So you might see this rewritten as minus 4 over x square root of x. They do this in the textbooks oftentimes. But so now that you've seen this, you don't have to do it, but if it's in a multiple choice, they might not have your version of the answer. They might have this version of the answer. So be able to at least recognize that that's what happened there. And then 4 over x squared. So this is also a valid, correct answer. And again, in the multiple choice section, this might be the way they write the correct answer. And, they might use the square root stuff, and you go, they don't have my x to the 3 halves anywhere. Well, they do, but they have it in a different version. Okay? Does that help? Okay. So, dealing with fractions is always difficult. Negative exponents is always difficult, challenging. But I think that the test is really fair. They did not make it. The homework should be more difficult. In fact, the homework is, at least as far as complexity, more complex and difficult than the test. The test is pretty straightforward. If you've gone through the homework, you'll be fine. Even if you haven't, if you've gone through the review, you'll be fine. y equals x times the square root of x. And what was the question asked? Was it asking for the derivative or? Okay. Well, on this one, again, we could go two routes. We could use the product rule to find this derivative, or we could use algebra. And again, that's the thing is they, even though they may want the product rule, we could use algebra. And remember, this is x times x to the 1/2, which is x to the 3/2, right? This is 2 over 2, which is 1. You add the exponents, it's 3/2. So one sort of, I think the simplest way to do it is going to be write it this way, bring this down, subtract 1, which is subtracting 2 over 2, right? And so our answer for the derivative of y would be 3/2. X is up in the numerator, and notice 3 minus 2 is 1/2. And so our derivative is really 3/2 square root of x. We could write it this way. Okay. And again, you could use the product rule, but in this product rule would be like overkill. It would be harder to do the product rule but you could. And the ones that, the free response ones, if they give you a product rule one, it's something that would really need it. It wouldn't be something like this where you could choose either one. But this one will get you there. Does that help? Okay. All right. So I think what's best at this time, if you've got individual questions, I'm still here to answer them. If you want to work on things, but it's best if you can get all the way through the review, find any questions. Thursday, we'll come back and any questions you have are there. If not, just take a break and relax, get plenty of sleep, and then we're ready to go. Let me